Hi guys, today I'm going to be working through the examples from exercise 3.6 from your Year 11 Jacplus textbook. So in this exercise we're going to be determining the rule of quadratic polynomials, and that's from the graphs that are given. So they do give us a few handy rules here. So it tells us if the turning point is given, we use this form. If the x-intercepts are given, we use this form. And lastly, if 3 points are given, we use that form there. So that's handy to remember. And actually the first step when you do any of these is that you should identify what form it is and which form of the equation you'll use. So for this one here, what we see is that we're given the turning point and we're given one other point. So with the turning point and one other point, we can identify the form as turning point form. And how that looks is y equals a x plus b squared plus c. And you can use h and k if you prefer. It doesn't really matter. So now what I want to do, step 2, is put the obvious information in. And what we know is that the x value of the turning point, well, that's going to be given as the opposite of what is shown. So here it's a 1, it's a positive 1. So that means we've got y equals a x minus 1 squared. And then we put the same for the y value, so minus 4. So if we were drawing this, if they gave us the rule, we would know that the turning point comes from the opposite of this value, so it would be positive 1, and the same as this one. So that's where our turning point of 1, negative 4 comes from. Now that we've got that, we still need to solve for a, and a lot of people will forget to solve for a. So once they put the turning point in, they will just put it like that, and it may or may not be correct. A might be 1, and if A is 1, then you're lucky, you would be correct. But if A is not 1, then obviously you won't be correct. So step 3, we sub in the other point to find A. And A is our dilation. So let's sub in that other point. And this time the other point is the y-intercept. So it's 0, negative 6. Be careful that you don't accidentally do negative 6, 0. That's quite a common mistake. So 0, negative 6. That means that y is negative 6. A and x is 0, and now we can solve that. So negative 6 equals a, negative 1 squared is 1, minus 4. Let's add 4 on both sides, and we get negative 2 equals a. And what we see here is quite important. The value of A is negative, so that's taking into account the dilation and the reflection. So it means that if you had considered that this is an upside down graph to begin with, so yes, it's going to be a negative graph, and it will have a negative in front of the A value, but if you had put that negative in to start with, then you would be coming up with the wrong value for A. You may get the wrong answer. So it's important not to consider whether you are a positive or negative graph. The A value will determine whether it is positive or negative. So our final equation, so I guess we could say step 4, final equation. This is where we actually answer the question. It's asking us for the equation of this graph, or the rule for the following parabola. So y equals A is negative 2, x minus 1 squared minus 4. And that is the answer that we would highlight or box, so it's not lost amongst the working out. So that's the first one. And notice that this one, the features, as we said, were the turning point and one other random point. And that other point, it was a y-intercept this time, but it could have been one of the x-intercepts. It could have been just a random point. The only thing that must be there is the turning point for us to use turning point form. Let's move to the next one. And in this case, they are giving us two x-intercepts. Two x-intercepts, and we've got another random point. And the random point given here is a y-intercept. And it just so happens it's a y-intercept again. It certainly doesn't have to be a y-intercept. So step 1, where we choose the form, we can say this is x-intercept form because we've got the two x-intercepts. So we'll say y equals a. A is again our dilation, and it will take into account whether we've got a reflection or not. X, you can now write as you wish, minus b, minus c, whatever. I'm just going to write plus b and x plus c. And I've purposely chosen different values here. So in the book, they give us this x1 and x2, and in the first example, they give us h and k. And h and k is generally used for turning point form, but it doesn't matter what values you use, what polynomials you use there. You will still be able to find your correct answer. So now that we've chosen the form, step 2, as we did before, we put the obvious information in. And in this case, the obvious information are the x-intercepts, because if we were solving this, if this was a equation that we had to find our x-intercepts, then we would solve this to equal 0 and we'd solve this to equal 0. So we would find that x would equal negative b and negative c. So in the same way, we can say, well, y equals a, x, this 1 is negative. So if I write plus 1, when I solve x plus 1 equals 0, that will give me x equals negative 1. So that's why I have the opposite value there. The second one, my x-intercept is 4. It's positive 4, so I need to write x minus 4 there. So at this stage, I've got maybe 2 out of 3 marks or 1 out of 2 marks. And now I just need to find a. And as I said for the previous one, the a value is the one that people will forget to do. So 3 sub in the other point to find a. And again, I really stress that in both of these, they've given us a y-intercept as the other point, but it doesn't have to be the y-intercept. It can be really anything. So let's see, our y-intercept is at negative 2. Negative 2 equals a. X is 0. Of course, the y-intercept is very convenient because we're eliminating the x's there. So we end up with a times negative 4 is negative 4a equals negative 2. And when we divide by negative 4 on both sides, we're going to get a equals half. And again, you can see that I didn't need to account for whether this was a positive or negative graph. Because of the maths, it ends up that my a value is positive. So now I can state my final answer, and I'm going to say y equals half x plus 1, x minus 4. And be careful to actually complete the question. So this is the actual answer here. So we want to make sure that our fourth and final step is to actually answer the question. So you found a, you found, the values to put in here, but if you don't put it as one equation there, then you wouldn't get 4 marks. So that's the second type. The next one is one where we've got 3 random points. So in this case, they haven't shown a picture, but I will. We've got a point at 1, negative 4. So maybe here. We've got a point at negative 1, 10. And we've got a point at 3, negative 2. So it might look something like this. And we're not given the turning point here. We're just given 3 random points, not the turning point, not the x-intercepts, and not the y-intercept. So 3, neg 2. So let's say it looks something like that. We can't use the x-intercept form because we haven't got x-intercepts. We can't use the turning point form because we haven't got a turning point. So I guess you could call the third one the 3 random point form. So choosing the form, it would be the 3 random point form. So what we need to do is we say y equals ax squared plus bx plus c. So notice that the other two that we did, so the one in x-intercept form and the one in turning point form, we could expand those and we would get it into this ax squared plus bx plus c form. But there's no use in doing that because it's easier to use the x-intercept form if you've got x-intercepts and easier to use turning point form if you've got the turning point. Also note that our final answer for the previous two, we didn't expand, we just left it as it is. It was fine. For this one, because we've got 3 random points, we're going to need to use this form, the quadratic form here. So I'm going to sub in each point. Sub in each point. There's no obvious information in this case. So let's do this one. So y is -4 equals a, x is 1. So that gives us -4 equals a plus b plus c. So that's one equation, and you could, label it number 1 if you wanted to. I personally don't see too much value in doing that. I think if you just write the 3 equations, they don't need labels. So the next one, it's -1, 10. So y is 10. So that gives us 10 equals a, -1 squared is still 1. So a minus b plus c. So this can be our equation 2. Again, label it if you want. No need to if you don't. Third one, let's do that in a different colour, maybe blue. So the third one, the point is 3, -2. So -2 equals a x, which is 3 squared, plus b times x plus c. So that is -2 equals 9a plus 3b plus c. And there is our third equation. So now we've got 3 simultaneous equations and we want to eliminate the variables, or each variable, so we're able to solve for a, b and c. So let's do that. So step 3, eliminate and solve. So I'm going to say maybe this one, equation number 1, and I'm going to subtract from equation number 2. That will be quite nice. So you want to look for the ones that are going to be easier to work with. So I'm going to subtract -4 equals a plus b plus c. And I've chosen these two because I can see I can eliminate 2 of the variables here. So that'll be quite nice. 10 take away -4, that's a double negative, so it's positive, equals 14. A minus a is 0. -b minus b is -2b. And c minus c will be 0. So I'm left with -2b equals 14. And then I can divide by -2 on both sides, giving me b equals -7. So that's good to know because it means that in all my equations I can replace the b with a -7, and I'm going to do that right now. So in the first equation, let's change that to a -7. And in the second equation, let's change that to a -7. So that's going to be double -7. And in the blue equation, let's change our b to -7. 3 times -7 is -21. So our 3 equations now, I can write a little bit more neatly. The green one, I'm going to add 7 on both sides. So that's going to be 3 equals a plus c. The red one, I'm going to minus 7 on both sides. So it's going to be 3 equals a plus c. So that gives me the same thing. It's not as helpful as I would like. And then the third one, well, that's going to give me, I'm going to add 21 on both sides. It's going to give me 19 equals 9a plus c. So obviously if I put these two together, I'm going to end up with nothing because it's the same equation. If I subtract them, I'll end up with 0 for everything. But if I choose my 9a plus c, well, that's a good one. So I might do these two, and I'm going to say, well, 19 equals 9a plus c, and underneath I'm going to write 3 equals a plus c, and I'm going to subtract. So that's going to give me 16 equals 8a. C minus c is 0. Divide by 8 on both sides, it gives me a equals 2. So now I've got 2 of my variables, and really now I just need to sub in to find my third variable of c. So I'm going to choose this equation here and say 3 equals A, which is now 2, plus C, which means C equals 1. So now I've got A, B, and C, and a lot of people will stop here. And sometimes the question will say, find the values of A, B, and C. If they give you this, and they'll say, find the values of A, B, and C. But this one is asking us to determine the equation. So our final thing to do, our fourth step, would be to actually answer the question. And we always want to actually answer the question. So it's y equals ax squared plus bx plus c. So that means y equals a is 2, b is -7, and c is 1. So this would be our final answer. So there's an example from each of the 3 types, and that completes the example for exercise 3.6.